GenBand proudly welcomes another key NFV ecosystem member and technology partner, Renu Navale, Director of Intel Network Builders.
There must be some kind of way out of here.
Good afternoon, everybody. Before I start talking about what Intel is doing to drive network transformation, I first want to say kudos to the GenBand team. It's been a fabulously organized conference. It's been a great couple of days, and I think the rest of the week also promises to be fantastic. So thank you. And if I start speaking with three-letter acronyms, somebody please raise your hand. A lot of us from Intel are always guilty of speaking in TLAs. Most of today, you've heard several people talk about what's happening with the network transformation. You heard Werner speak about network function virtualization. It kind of taking a step back. It's, if you look at what's been happening with the connected devices, 4.9 billion connected devices in 2015, and likely to grow to about 50 billion Internet of Things connected devices by 2020. All of this leading to a continual surge in data traffic. It's been growing, doubling annually since 2011. When we look at all of this, how is our network infrastructure going to deal with these billions of devices and the surge in internet and data traffic? And of course, if it's smart and connected, we like to think that it's best with Intel as well. As a company, Intel has products, technologies, software solutions that powers end-to-end solutions for this mobile world. We have silicon, compute and communication silicon, chipsets, Ethernet controllers. We have standard hardware and software technologies that can help create this smart network as well as power new mobile experiences. And underpinning all of this is the Intel security solutions that we have that can help create, help satisfy the demand for real-time and protected data that almost any one of us with connected devices has. Let me first also talk to you a little bit about the data center group. That's the group that I'm part of within Intel. And this helps to helps look at the entire, enterprise IT, cloud service providers, telco service providers, as well as technical computing market segments. It not only addresses the breadth of opportunity across these verticals, but also the diversity of requirements that our customers from these verticals require. We have a portfolio of products that ranges from the Intel Xeon processors, the Intel Xeon Phi, as well as the lower-end Intel Atom processors in order to help satisfy this diversity of customer and user requirements in these verticals. In addition, these technologies, we have technologies for server, storage, and network, both hardware and software technologies that form part of what we call our standard hardware and software COTS, or standard high-volume server technologies that are essential for these different verticals. When we talk to our customers in these verticals, enterprise, cloud, telco, in addition to dealing with these billions of devices, the surge in the data traffic, the one thing that we hear almost consistently from all of them is, one, they want to lower their cost of ownership. Two, they want to optimize their cost of service delivery. And three, they want to be able to rapidly deploy new revenue-generating services. In order to, again, satisfy these demands, the number one thing that we are looking at is how do we ensure that the infrastructure upon which all of these things can be built upon is, agile, nimble, flexible, responsive, and efficient. So let me go into a little bit more around what Intel is doing in order to help create this type of a flexible, responsive, and efficient infrastructure. I like to call this the circle of life. We're doing, 4 things. The number one is we're making a number of contributions into open source and standards that help to, again, drive network transformation, make the standard hardware and software building blocks that we provide be suitable for networking. The networking demands of real-time, protected, carrier-grade, all of those critical requirements that I'm sure Genband and all your customers and folks are intimately familiar with. So we're making contributions into open source and standards. The second is around integrating some of these hardware and software contributions into a reference architecture called the Intel Open Network Platform. So I'll talk to you a little bit more about that. And then we also have, we're driving and enabling an open ecosystem on our architecture. And then last but not least, we're working closely with several of the key global service providers, as well as telco and cloud service providers, to collaborate with them on trials and deployments. Let's start with the first one, which is around the open source and standards. In order to help make the standard hardware and software building blocks be suitable for this responsive, agile, nimble, flexible, efficient infrastructure, we are making contributions into a variety of different open source standards. One example is our contributions around network virtualization encapsulation protocol called Genevieve, which we're making into the IETF. We're also making contributions around what we call EPA, or Enhanced Platform Awareness, which allows us to intelligently place virtual machines or virtual network functions and also take advantage of various silicon features, silicon instruction set, PCI Express placement, SRIOV, I/O functionality, memory access, all of these different silicon features and functions that an orchestrator can take advantage of. We're making these contributions into OpenStack. We're making policy and service chaining contributions into Open Daylight, as well as, again, IETF around the network service header. The network service header inserts certain key intelligence into the network packet header that allows it to determine which service functions it should get routed into. If you think of virtualized network functions in the form of a service chain. And last but not least, a number of packet processing accelerations in the form of what we call DPDK, or the Data Plane Development Kit. This is all open sourced. The Open vSwitch, which also includes the packet processing accelerations. There are some service assurance challenges at the node, and we're currently working on some open source contributions with regards to service assurance as well, around how we can use normalized compute units or CPU core pinning in order to guarantee performance, power, thermal quality of assurance. In the second thing that Intel is doing is delivering open reference designs. With what we call as the Intel Open Network Platform, it's a reference architecture. It's not a commercial platform. It's a reference architecture. It integrates our processor technology, our Ethernet controllers, various software ingredients like the data plane development kit, the Open vSwitch, some of our OpenStack enhancements, and several other contributions into a reference architecture or a reference specification. This is released on a quarterly basis on o1.org. Now, how this goes into market is some of our strategic partners actually take this reference architecture, they can take ingredients from this reference architecture and create a commercial platform. I'll give you one example of such a platform, which is, you just heard Werner speak, and HP has what we is a first commercial deployment of the Intel ONP server. They have taken several pieces or ingredients from the ONP, our processor, Ethernet, the data plane development kit, Open vSwitch, some of the the EPA enhancements into OpenStack, all of these in order to produce the first commercial deployment of Intel ONP. And as I've understood, almost 2 weeks ago, they announced production-ready NFV solution kits that can be distributed to service providers and ISVs. Okay, it's not moving forward. Okay. So in order to, the next thing that we're working on is, sorry, it went forward a few slides. But the next thing we're working on is building an open ecosystem on IA. Before I get to this slide, I'm going to speak on a slide that I skipped on. In order to drive an open ecosystem on IA, we launched a program about 18 months ago called Intel Network Builders. This has grown tremendously from about 30 founding partners, including HP, to about 150 partners right now. We focus on 3 main things as part of this ecosystem program. The first one being around technical collaboration, proofs of concepts, technical support, hardware loan program. We also work closely with all our partners, including GenBand, on several marketing, collateral, solution briefs, webinars, etc. And lastly, a lot of matchmaking that we also drive through this program. In order to facilitate matchmaking, we actually have 6 of the leading telco service providers, NTT, SK Telecom, Telefonica, China Telecom, Etisalat, and America Mobile, who've actually joined this program because they want to be in close connection with our partners. They want to be able to connect and collaborate directly with the ecosystem partners, check out their solutions and products, and determine which ones that they could then take into trials and deployments. So this is a great opportunity for our partners as well to be able to showcase their solutions directly to some of these end users or end service providers. In order to help collaborate on some of our trials and deployments, we started this journey actually quite a few years ago, this whole NFV and SDN journey. We started in about 2011. We started to, becoming a trusted advisor to several of the global leading service providers. We started to work closely with them within what's called the ETSI, which is the European Telecommunications Standards Institute. We started to work on the ISG or the NFV working groups with them. Collaborated with them through various proofs of concepts. And since last year, we have started to see a number of these proofs of concepts and trials actually go into deployments, like the Vodafone Telco over Cloud, the AT&T User-Defined Network Cloud, British Telecom's Virtual SBC, Verizon's WAN and cloud bursting deployment, Telefonica's virtual CPE, which is again with, with the HP Unica project. So all of these have started to go into commercial deployments, and there's a lot more being planned through 2015 onwards in various geos for NFV and SDN deployments. In summary, I think the shift to software-defined networking and network function virtualization has just started. We're starting to see a number of deployments, but there are key barriers still. Our standards are still maturing. Interoperability is still key amongst all our partners. Integration with legacy equipment as well as the OSS and BSS systems is also critical. So overcoming all of these barriers is really critical to unlocking this transformation. And Intel is partnering not only with GenBand, but with several other partners in this ecosystem through the network builders to lead this transformation. Thank you.